Let me guess. You've heard this sentence before. A class is a blueprint and an object is an instance. And technically that's correct. But if that explanation actually worked, you wouldn't still be confused. Because the real problem isn't definitions. It's that most people don't feel the difference. They write classes, they create objects, but in their head, everything still feels like the same thing. And that confusion matters because mixing up classes and objects is one of the fastest ways to design brittle, confusing systems. So in this video, we're going to do one thing. Remove that confusion completely. By the end, you won't just repeat a definition. You'll see why classes and objects are fundamentally different and why that difference changes how you design software. In the last video, we talked about why object-oriented programming exists. Not as rules, not as syntax, but as a response to growing complexity. We said object-oriented programming is about ownership, about giving behavior a home, about making change safer. But none of that works until we answer one basic question. What actually owns things in a system? Is it the class or is it the object? This is where most people get stuck, and everything else starts to feel abstract. You've probably heard this explanation. A class is a blueprint. An object is built from that blueprint. That sounds reasonable, but it hides the most important detail because blueprints don't do anything. They don't change. They don't fail. They don't have problems. Software does. Confusion starts when we treat classes as if they were the real active parts of the system. Instead of instructions for creating those parts, blueprints matter. Without them, nothing is consistent. But they're not alive. They define how things are built, not how they behave once they exist. Let's make this concrete with a simple story. Imagine a restaurant. There's a menu. It lists dishes, ingredients, and prices. That menu describes what could be ordered. But the menu is not food. When customers arrive, actual dishes are cooked. One dish might be hot, another cold, one overcooked, one perfect. Same menu, many dishes. The menu never changes. The dishes do. In this story, the menu is the class, the dishes are the objects. And the moment a dish is prepared from the menu, that's instantiation. The confusion disappears once you see this. Here's the mental shift that clears everything up. A class exists as code, as a description of how something should look and behave. But when your program runs, it's the objects that actually exist. Objects live inside your system. They have state, identity, and a life cycle. When bugs happen, when data changes, when something goes wrong in production, it's always an object, never a static class definition. This is the most important sentence in this video. A class never holds changing data. Only objects do. Classes describe structure and behavior. Objects carry state. Here's what that actually means. This class doesn't change. It's just a definition. These are objects. One can change, the other might not. Different state, same class. The class stays exactly the same. If data changes over time, you're dealing with an object. If nothing can change, you're looking at a class. Let's bring this back to real software. Imagine a user class. The class defines what a user has and what a user can do. But the class is not a user. Here's how this confusion breaks real systems. A beginner puts changing state on the class. Suddenly, every user is logged in. That happens when you treat the class like the object. When your system is running, you don't have the user. You have many users. Each one is an object. Each one has its own state, its own data, its own situation. One user is logged in, another is locked. Another hasn't verified their email. Same class, different objects, different realities. This distinction is where design either works or quietly falls apart. Many beginners design systems around classes. They think in terms of files and folders. But real systems don't behave through files. They behave through objects. So the better question isn't, which class should this logic go in? It's, which object should own this responsibility? Because objects represent real things in motion. Classes do not. This is why object-oriented programming works when it works. You don't reason about the entire system at once. You reason locally. One object, one responsibility, one piece of state. Classes give you consistency. Objects give you reality. Confuse the two, and your system feels abstract and fragile. Separate them clearly, and your design starts to feel natural. So here's the mental model to remember. A class defines what could exist. An object is what actually exists. Classes describe. Objects live. Classes don't change. Objects do. If this distinction is clear in your head, the rest of object-oriented programming stops feeling mysterious. Now that the difference between classes and objects is clear, we can finally talk about something critical. How do we stop other parts of the system from breaking our objects? How do we protect their state and enforce their rules? That's what encapsulation is about, and that's the next video. If this made classes and objects finally click for you, you'll want to see that.